Now let's create this press tool assembly design. So with whatever the parts already we have created in earlier tutorials. So to create that, just we will enter into start mechanical design. Then already we have created parts and we have saved it to one separate folder. So to call that parts in assembly design, we can go here with existing component. Just click on the product. Now, according to this assembly, I need to start with this base part. So just I'll select here bottom plate. Let's make it open. Then whenever we are going to design an assembly design, always one base part will be fixed. So to fix that part, as we can see here under constraints toolbar, we can use this fix component and we can click on the part. So as you can see, this part will be fixed here. Then next to that, we need to call this guide pillar. So to call that guide pillar, we can use here existing component with positioning. Why I am not going to use this option means, so if I use the same option, for example, I will call this guide pillar, that exactly it will come and settle here. But we need to move this part somewhere outside. So in that conditions, so we can use here existing component with positioning, click on product. Then we need to call guide pillar, let's say open. We are able to make proper position somewhere here outside. Let's say okay. Then this guide pillar we need exactly for this all four holes. So in these conditions, for example, same guide pillar we want for all these four holes, we need to assemble this main part to the original hole. It means these four holes already we have created by using rectangular pattern in part design. So if you want to use this same guide pillar at all four holes at a time, we can use one option called reuse pattern here. So to use this option, first original element should be assembled to the original hole. Now let's check which is the original hole. So this is the bottom plate. Just we will open here, again here plus, again click on here part body plus. So before pattern, whatever the hole we are having here, this is the original hole. So we need to apply relations only for this original hole now. So to make here properly constraint, we'll go with coincidence constraint. Just turn off this pop-up and say close. Relation we need between axis to axis, we need coincidence. Then after applying relation, we can have it here update option. So just we can click on this, or else manually we can use Ctrl plus U as shortcut key. So just make it update here. Then next to that, this downside face, it should attach with this bottom plate bottom face. Again I'll go here with coincidence constraint between this face to this face. So we need here same direction. If I keep it opposite, guide pillar will get reversed. So we need here same. Let's say okay and update. So properly it will settle at that part. Then here rotation will be there for guide pillar. So to check that rotation, on guide pillar mouse right click. Under delete we are having guide pillar object. You can check here component degrees of freedom. If I click here, we are having rotation with reference to this Z axis. So to lock that rotation, we need to use here angle constraint. Then rotation we are having with reference to Z axis. So to apply parallelism relation, we are going here with angle constraint. We need to select the plane which is having relation with Z axis. Means either you can select ZY plane or ZX plane. For example, I'll select this plane. So this plane, it should be similar to this parallel. So let's make it here parallelism. Say okay. Now for the guide pillar, if we check here component degrees of freedom, as you can see, there is no degree of freedom. It means this part is not able to move in any direction. Properly this part is fixed there itself. Then same guide pillar we need for all these three holes. So as already we know that all three holes we have created by using pattern. So directly we can go here with reuse pattern. Component is this. Then here two types we are able to see. Pattern definition means multiple guide pillars we are able to get here, but relations whatever we have applied for original one, it will be not copied and pasted here. So in this condition, we won't use this pattern definition. We will click on generated constraints. So generated constraints means whatever the relations we have applied for this original part, along with this part, constraints also will get copied and pasted wherever we want. So always we need to use generated constraints. Then component is this, we need on this holes. Let's say okay. Now if you check for any part degrees of freedom, it will show there is no degree of freedom. So this is the proper way to create this assembly design. Then next to that, I am going to call this top plate. So by using existing component with positioning, just we'll click on product. We need to call here top plate. Just I will adjust somewhere here upside. Let's say okay. Now same here we need coincidence. As we can see from top view, just I'll change here top view for better understanding. Whatever this edge face we are having, it should be exactly connected with this edge. So just we can select this face and this face. It should be on same direction. Let's say okay and update. So from top we got proper shape. Then again if I keep it here front view, in this direction we need this face and this face should be straight. So just we'll select this face to this face, make it here same direction coincidence. Then next to that, this top plate, it is able to move in up and down direction. As you can see with reference to Z, it is able to move up and down direction. Now as you can see here with reference to this assembly design, we are having gap here. So whenever we want to give dimension between face to face, in that condition you can use here offset constraint between this face to this face. Let's say example some 250 dimension I'll give and I'll make it update. Later we are able to edit this. Then let it be aside. Now for this top plate we need to assemble this guide bushes also. Again existing component with positioning under this product. We need here guide bush. Let's open that. Then same I will drag and keep it somewhere here. Here also we have created only one original hole and remaining we have created with pattern. So first we need to check which is the original hole. So for this top plate I will click on this plus part body plus before pattern. This is the original hole. So we need to apply relations for this guide bush to this original hole. Same we will repeat here. Coincidence between axis to axis update. Again coincidence between this top face to this top face will select same direction update. So to lock rotation we will go for angle constraint. Rotation is with reference to Z axis. Just I will click on this plane to this plane. We will make it here parallelism. Let's say okay. Now if I check degrees of freedom for this part, here there is no degrees of freedom for guide bush. Now same guide bush we need for all these three holes. Directly we can create here reuse pattern, generated constraints, guide bush for these holes. Let's say okay. Now later according to this should be visible properly. So I will double click on 250. I'll make it here some 120 length and let's make it update. So proper position we are able to see here like this. Then as you can see for this assembly we are having axis systems and constraints are visible. So we'll get little like confusion here. So to hide everything at a time, in specification tree constraints mouse right click, we can hide all constraints at a time. Then if you want to hide all axis systems at a time, go here with Control plus F. Then in this pop-up workbench we need to select here part design. Type we need to select here axis system. Then here search and select we need to click. Then here hide or show option will be there. Just click on this. At a time all axis systems will be hidden. So in this way you can create this assembly design like this.